Okay, so in this video we will solve this CAD test. Within 60 minutes we have to solve this CAD test. So here you can see the task. So we have to create close volume, we have to create two bosses and one snap, and it should be parametric. So you can see the reference image also. Okay, so let's start now. So this is the A surface and the master section given. So first I will create all the surfaces. So inside this A surface, first I will join all these surfaces here. Okay, after joining this we have to disassemble this and delete this join. Okay, so we got all these A surfaces. Okay, so now we have to join all these surfaces to check the feasibility of the surface. So here we have to hide original surfaces like this. Okay, so this is the A surface now. This is the final A surface and there is no issues of tangency. So actually there is one sharp edge, it is like that only. Actually that is a step there. Okay, so now we have to create the B surface now. So first I will create one plane on this section and one more plane on this section. Like this. So on these planes you can take a section cut to see your surfaces are matching with the master section or not. So whether your part is okay or not, you can check it from here by taking section cut. Okay, so now what we have to do, we have to first create the B surface now. So I will insert one geometrical set here for the B surface. Okay, sorry, so first we will create the tooling direction. So first we have to create tooling direction. So to create the tooling direction we can take help of this feature. We can take help of these B-side features to create the tooling direction. So here we will create one center point first on this curve. Then after that we will create one more center point, and okay, so in this way we can create the tooling direction passing through these 2 points. So this is the main tooling direction now. So I will just isolate this, delete these 2 lines, and so here you can give the coordinates to these points. Like this. So this is the main tooling direction. Okay, so now we have to create the B surface now. So the thickness, you can measure the thickness here from the master section. So the thickness is 1.5 here and here as well, but on this side the thickness is variable. Okay, so at this section the thickness is 1.98. Okay, so there is a draft angle of 1 degree. And this is also 1.5 mm. Okay, so now we have to offset these surfaces by 1.5 mm first. Like this. Okay, so if you take a section cut now, then you can see this is matching with the master section. So we will create the B-side features after creating the close volume. So here you can see we have to extrapolate this edge first up to here. Okay, so instead of that I forgot to offset these surfaces also. So we have to offset these surfaces also. So let's offset these surfaces. Okay, so now if you take a section cut, then you can see it is now perfect. So you can see the angle is 2 degree here. So just observe this carefully. So you have to observe this very carefully. So here we have to offset these surfaces by 1.976 mm like this. So as you can see, this surface is not matching because there is some angle between the surface and that master section. As you can see here. So this is 1.5 mm distance between that edge and that point. So we will first measure all these distances. So this is 1.976. Okay, so what we will do, we will create one boundary here, and let's take one parallel curve at this distance like this. So now if you take a section cut, then you can see this is now matching. So we have to simply split this surface using this curve. So at this section the distance is different, so here we have to use different distance here. So what we will do, so I will just go back and I will separately create all these parallel curves here. So this is 1.412 mm. So let's copy this and this is also same 1.4 mm. So on these two sides we can take parallel curve now. So in this way we have to connect these curves by using spline. Okay, so let's project this. So before that we will just join all these curves first, and after joining this we have to project it on the surface. So in the split we will use projection. So let's create the projection and split this surface like this. So as you can see, the angle is 1 degree, so we have to use sweep with reference to surface command here to create that surface. So here we will select with reference to surface, and in the guide curve select this curve, and in surface select this surface, and the angle is 1 degree. Okay, so in the length too also we will extend this surface. So we have to extend this surface like this. So as you can see, now the surface is okay. Still there is some gap here. Okay, let's hide that surface first, and then let's take section now. Okay, so now as you can see, the surface is perfectly matching with the master section. So this distance is 0.8 and the angle is 1 degree again. Okay, so in this way we have created this corner, and on that corner we can give the edge fillet. Okay, so now here we have to create that step here. We have to create that step, as you can see here. So first we will offset this surface by this distance. So now you can see here also we have to apply the 1 degree angle. So we will follow the same procedure again on this surface. So the distance is almost same everywhere. So what we will do, I will simply create one complete boundary and I will then use the parallel curve here like this. Okay, so now we can split this surface. Okay, so as you can see, the surface is perfectly matching with the master section now. So here if you measure the angle between these two lines, then you can see it is 93°. So here we have to use sweep with reference to surface at 93°. So we will create one surface at 93° like this, in this direction. Okay, so I think angular sector is wrong, so we have to take this angular sector. Okay, now let's check. So as you can see, now the surfaces are perfectly matching with the master section. Okay, so now let's split the unwanted surfaces like this. Okay, so as you can see, in this way we have created the complete B surface. Let's join all these surfaces now. Okay, so here we will apply the edge fillet. So the surfaces are perfectly matching, as you can see. So now we just have to create the closing surface now. So let's create the closing. So as you can see, on that corner we can give the edge fillet ladder. So I will just create one geometrical set first for the closing. After that, let's create one boundary on this edge and on this edge, and then we will use blend command to close this. Okay, so this is perfect. The surface quality is not good, so what we will do, we will use couplings here. So just apply the couplings properly. Okay, so this is done. So now we have to create closing on this side now. So for that we have to first measure the angle between this. So it is 87 degree. So we will create sweep surface at 87 degree here. So let's create one boundary first, and then we will sweep this boundary with reference to surface at 87 degree, like this. So the angular sector is wrong, so we will select this angular sector. Okay, so now it is perfect. Let's see. So as you can see, this is now perfect. So this is perfectly matching with the master section. Now now we have to split all the unnecessary surfaces. Okay, so this is the final A, B and closing surfaces of this part. So now we will join all these surfaces together inside this geometrical set. Okay, and after that we will create close volume. Now we will make it solid, so you can check if there is any opening. So there is no opening, so we can now convert this into a solid part. Okay, so as you can see, in this way we have created this complete close volume of this part.